this 80 series Land Cruiser transfer case rebuild series. In this part, you're going to watch George finish the teardown of the transfer case, and he's also going to show you the necessary modifications you need to do to the cases to fit the larger gear that is part of the modification we are doing to this transfer case. So let's get back to George's Valley Hybrid shop in Stockton, California, and finish this teardown.
Next item I'd like to tear apart is a front extension housing, which is possibly the simplest assembly, but again, really good idea to keep all the components together. We already have the fork and the slider out of it. So now we're going to take a snap ring out. This one, you can see it here, retains this hub that the slider rode on onto the shaft. So again, keep the components together, right? We have our shift fork, slider, and the first snap ring. At this point, you can do the same thing we did with the rear extension housing. You can sit this on the bench on a rag like this and tap on it. You don't want to damage these splines, so you can use a dead blow hammer, or you can put it in a press, support it in a press somehow, press on this shaft. We made a fixture a while ago on our plasma table that makes our life easier. Since we showed you on one extension housing how to do it manually per se, we're going to show you how the fixtures work. So this is something we built, and you have to have a big enough press for these guys, because for our fixture, this has to sit down between the press uprights. So like a small 20-ton press, not big enough for one of these. We made this to sit perfectly on there. So we have two alignment dowels. One goes here, one goes here, to keep it lined up. And then we have a series of bolts. So we're gonna take this over to the press and press it out. So this is a 50-ton press. The bed is wide enough for that housing to sit down in there. You can see one of our other fixtures we made years ago. This is a fixture for doing 80 series control arms. So the arm gets retained in here, and then we can push the bushings right out with the right bushing press tool. We have another portion over here for doing the other control arms. If you're doing control arms, this is the safest way to do it. It's not fun having one of those come loose in the press. There's not a lot of pressure on these, but I always hold on to this guy output shaft. Again, if that slides out and hits the ground, you're gonna damage those studs. It doesn't all of a sudden just let go. These are mild press fit.
Can you operate that electrically and manually?
Yes, yeah, we have the electric attachment for it. I like feeling this kind of stuff, so I'd rather have the manual control on it instead of just listening to the motor block down and then something finally goes flying. I'd rather feel how much pressure I need to put on it. So it popped loose, reach underneath there, nothing else will come flying out. Only one set of splines on here other than the one in the differential, and that is for that front hub. Bearing sits here, seal sits here. So we're gonna sit that in there, release the pressure on the press, and we can go back on the bench. We've wiped the shaft down a little bit, and then to go back to the oiling circuit on this and how the system works. This is our rear shaft, this is our front shaft. Oil comes in through the sealing rings, travels through the shafts. There are a couple of oil holes in this shaft to make sure oil goes to the proper spot. This guy sits in there, and if you look at this closely, you'll see that there's an oiling hole here, there's an oiling hole here, and there's another one here. And that makes sure that these two are in the differential assembly, which we'll look at later. Make sure that there's good oil flow, pushing oil and circulating oil through the case instead of it just sitting there and doing whatever it wants to do. So again, let's keep all the components organized. Front output shaft goes with the fork, slider, and the one snap ring. And we're gonna take this hub. These hubs never give trouble. It's good to look at the splines, but it's really, really uncommon that we see any damage. Now, you can see there's a bearing in here, just like the rear, and a snap ring right here, and then there's going to be a seal. Very, very similar to the rear. So, same thing here. We're going to use a pair of screwdrivers. If you look closely at the case here, there is a cutout here that actually allows you to bring a screwdriver in so you can get the snap ring out easier. Twist the snap ring a little bit to create room. Come in with the big screwdriver, pry up a little bit. And again, that's as far as I go. I don't keep prying them all the way around, because then you get little aluminum pieces and possibly gouge things. And come in with a rag, grab the end of the snap ring, twist and pull. Works every time. Wipe it down, make sure there's no defects. Only issue we ever see is rust. Other than that, these guys don't go bad. So generally speaking, you can reuse these snap rings. If for some reason your snap ring pliers overextended the snap ring, you know, it looks like an egg, which is usually for the internal snap rings, not the externals, then at that point you want to replace the snap ring. So now do the same thing. Flip the housing upside down, drift and hammer, and just tap it out. That's the bearing. In this case, the bearing actually has this plate built in, which is a seal. It's not essential. It can be sealed or not sealed. It doesn't really matter. Wipe it off a little bit, look at it. You can feel it. These generally don't give a lot of trouble, but again, since we're changing everything in this transfer case and we're planning on rebuilding, all the bearings get changed. Sit that with the parts for our front housing, knock the seal out. Same thing again, go right here. There you go. Wipe this guy out, make sure we don't have any damage or gouges. Everything looks good. Then we kind of bolt it from the fixture. That pretty much finishes the teardown for the front output. We'll work on the gear sets next. Okay, now that we have both extension housing torn apart, we can focus on the gear clusters. First, we're going to do the smaller one, which is our idler assembly. We have to remove the bearing from each side. So we have a taper bearing here and a taper bearing here. I found the easiest way to do this, or the simplest way, so anybody can do it in the garage, is I use, this one happens to be an old Toyota head bolt, because you got to keep it all Land Cruiser. So that's a head bolt from a 2F. And then I just use a standard 2-jaw puller. And we're basically going to press off this bolt and grab this slider. The slider is going to press up on the gear, which is going to press on the bearing, and all three are going to come off in one shot.
So you're grabbing on the inside or underneath it?
You can go on either one. I like going on the inside. That way the splines that are below or that the slider goes on will not get damaged no matter what. If you have the jaw on the splines underneath here, then you can possibly gouge one of the splines, and then the slider doesn't want to move as freely as it should. So I prefer to go in the groove in the slider itself. I'll get my hands out of the way in a second so you can see where I put it. Groove in the slider, perfectly fine. It's not going to distort it because it's bottomed up against the gear anyways, but it's better than possibly gouging these splines. This is going to press down on the bolt, presses on the shaft, and in turn, we're going to pull on the slider, the gear, and the bearing. There you go. Now set it down, slide the puller off, and set that aside. So you have bearing, and I always lay these guys out. The easiest way to remember how they go is just lay them out in order. So you can take your bearing, start with that, then your gear, slider, and then there's another bearing. This is a roller bearing, supports the gear on the shaft. We can sit that in there.
Is that slider directional?
Yes, absolutely. Good question. If you look at it, straight cut on the bottom because it lives on this splined hub, and then it slides up to mate with that portion of the gear. So the upward facing side on this is chamfered. The bottom side is perfectly flat, so the splines would have a hard time engaging. It's a good practice to get into. As you take the parts off, sit them on the bench the way they came off. This gear is one piece with the shaft. If you're doing a 100 series transfer case, this gear is also one piece with the shaft, but the gear is slightly different. So if you change the high range gears on a 100 series transfer case, either to the overdrive or underdrive, then you have to run the 80 series input shaft and you have to run the 80 series counter gear, because this gear is slightly different and it will not mesh with the aftermarket gear sets for high range, overdrive, or underdrive. Low range on a 100 series, you can bolt right in without changing any shafts. If you change the high range, you have to pretty much change the guts of the transfer case. So we have those off. Now we need to remove this bearing. You can use a clamshell style puller on this if you have one. There's different ways of doing it. I found a puller that I really like that I use on this. It's one of these guys. Again, it's a snap-on. It's an adjustable puller. For my little pulling tool on this, I use an old drain plug. I ground the ends off so it doesn't try to thread into the housing here. Sits down on the shoulder, and that way the threaded shank on the puller, if it does any damage at all, is going to dig into this bolt and not distort anything in here. It doesn't really matter. This is not used for anything. It's just there to support the bearing. So this bore right here is not crucial, but I still like to protect them. So I have that little guy. This bearing's a little trickier because the bottom lip of the bearing sits below the gear and you only have so much room to come in here with a puller to grab it. So I found that this style puller works really well.
I like that style of puller that it bolts in and clamps it in.
So the jaws can't move as freely as the other puller we use. And in this case, you pretty much have to. Otherwise, if the jaws of the puller come out too far, then they're going to grab the bearing, but the cage itself,
You're going to tear it apart.
for the rollers, and all it does is distort the cage, the rollers fall out, and then you have the race stuck on there. So by having those jaws clamped down like this, and the long enough jaws, in theory, it should pull that off in one shot. There you go.
Here's a part number for that snap-on puller you just used to remove that bearing.
Okay, the last component we need to tear apart, well, second last, is our main gear cluster, our output cluster, which is the high-speed gear, the low-speed gear, and then our center differential housed back here. A couple snap rings, some stuff we have to press apart, and so on. We're going to start tearing this apart by first removing the center diff, which basically is a little differential like in your axles, and then flipping the component over. It's easier to tear it apart that way. So there's a series of 10 bolts here that hold your rear diff carrier to the shaft assembly itself. These are 14mm bolts. They're hardened bolts. These have to be torqued to a certain spec, which we'll go over when we put the case back together. For teardown, doesn't really matter what order you go in. Another thing worth mentioning, when you work any of this stuff, try to use 6-point sockets whenever possible. If you use 12-point sockets, you're much more liable to strip a bolt or snap a socket or whatever else. The 6 points are much stronger, they fit better, way less chances of stripping out a bolt or having any other damage or setbacks. Bolts are all the same. These can go in the parts wash. The only place in the transfer case where they're used are on the center diff, so no need to keep them separate. Okay, at this point, rear carrier is unbolted and should come off. You should be able to wiggle it off. If not, oh, there you go. You can tell, just like in your axle differential, you have side gears here that spin, then you have little spider gears or planetary gear. It's really a spider gear, and then another side gear. So this gear comes out. There is a thrust washer in here. Usually they're stuck on it from the oil. I normally wipe them off really good and then you clean them in a solvent tank, then they come off. They never just fall off. From the oil suction, they just stay on there perfectly fine. You can take this pin out, it literally slides up. There's a locating pin here that matches a hole in the cross pin. It also matches up with a hole in the rear carrier, and this should wiggle out and matches up with a hole here. Super important that it's in the right spot. On these little gears, there are also a pair of washers. These will slide off. And it doesn't really matter which side they go on. There is a way to check the thrust on these. Ultimately, I usually mic these washers and make sure they're still thick enough. And I feel that's why when I take them apart, I turn these gears and make sure everything feels smoothly. I inspect the thrust surface where this washer rides to make sure there are no gouges. In this case, we're going to replace that assembly with a spool, which is part of the part-time kit. So we're not going to reuse any of this stuff. The only thing we're going to use is this gear is going to stay in there as a placeholder because we still need to engage the splines from the front output shaft. Our front output shaft slides all the way through here and engages these splines. And that's how the front output is driven. So this gear has to stay there, otherwise it's in neutral. Gear comes out, thrust washer again usually stays on there. The top and bottom gear are identical, the washers are identical, so you don't have to worry about switching them or getting the wrong one in the wrong place, no such thing. The one thing you need to inspect on the center diff and on this main shaft right here is that gear rides in this bore here. You can see these grooves, these are oiling grooves, to make sure as it turns it actually moves oil through and creates oil flow for this thrust washer. But also there is a bushing here. If you look at it, you can see a really thin sleeve that's about 3/8 of an inch thick, maybe a little tiny bit more. You can also see an oiling groove here and here.
Yeah.
That's so, again, you get oil flow. You always want to clean out behind this. Usually there's a bunch of stuff trapped in there. And that's from this bushing wearing down over time. And it's a good idea to take your gear, make sure there's a little bit of oil on here. Put the gear in there. It should go in fairly snug. Should turn with a tiny bit of resistance just from the oil drag, but you should not have any side-to-side play. If you feel a little tiny bit, but you can't see it, that's perfectly fine. But if you can move this and you can see it, that means this bushing is worn out and needs to be replaced. Otherwise, the gear will canter in there. That'll get exaggerated through the front output, and then everything moves. You're gonna have vibration issues, you're gonna have noise problems, and you're gonna generate a bunch of metal particles that are then going to contaminate the case and require rework or repairs fairly quickly. So this bushing has to be inspected, made sure that it's still a good fit on this portion of the side gear and that there's no groove worn in here. The bushing is much, much softer than the gear. So usually it's the bushing that wears down, just like in any other case, like a cam bearing, something along those lines.
How do you remove that bushing? You have to get a little puller in there?
Yeah, you have to get a puller on there. You can drive it through from the other side with a specialty tool, but realistically you can get a puller in there and just pull out on it. Pilot bearing puller will get that out of there.
Okay.
Most of the time they're good. It's worth checking. The one time when we see these bushings go bad, and this is the same thing we see in differentials, is if you run different size tires on a vehicle, because then one tire is going to spin faster than the other one. So the side gears are constantly turning and wearing these out. If you run the same size tires, then this differential only gets actuated when you're going around a turn. And then it's only a very slow difference. If you have different size tires on the front and the rear, then the gear is constantly turning in here and wearing that bushing down. So all-wheel drive, four-wheel drive, run the same size tires. Okay, that concludes the differential portion removal. Now we're gonna flip this upside down and tear the rest of this cluster apart. There is a snap ring on here, so you can see the opening here. These snap rings are always stuck on here because there's a lot of gear thrust forcing things back and forth, so the snap ring always gets wedged against the top part of the groove. So anybody who works on gear stuff always has random tubing around that they use to knock bearings on or hit a snap ring or press things back together. So find the right size tube. You can use a socket too, and just tap it in a couple of spots just to crack it loose. That should make life a lot easier. Snap ring pliers. I put a thumb over it, so exactly what just happened prevents that snap ring from going and rocketeering off into the shop, and you'll never find it again. If you're worried about it, you can put a rag over it too so it doesn't smack your finger. So at this point, we can press off the hub, the bearing, the gear, and the slider. Very similar to the idler shaft assembly we did, other than we also have a hub on this one. So we're pulling a lot of things at once. Usually this is pretty tight, again, from all the gear thrust. So we made our own little special inserts for these guys. You can use any kind of plate. Sometimes you can actually use one of the seal installer kits, will fit in there perfect. Any kind of disc. You can put a giant bolt in here. You can even put a plate across here with a little hole in it for the puller to center itself. But then once it pulls, this is a pretty narrow shoulder. So on the initial pull, we have a fairly wide shoulder just to get it cracked loose. And then once it cracks loose, we have a much narrower shoulder so everything can slide past our little insert. So just like on the idler cluster, I like pulling in the groove in the slider itself, because the slider is going to bottom out on the gear anyways, distribute the load that way, and we run no risk of damaging the splines that are below the slider. So we're going to start, just crack it loose. You can see that this distance is starting to close up. And once it gets tightened down like that, and we got the initial pull, then I change my insert. Obviously, depending on what you're using, you don't have to go through the extra step. Okay, now we can pull the assembly off. So you'll see this distance increase as I pull on this guy. So this is a split bearing. And again, try to lay these things out in order. So we have a snap ring, then we have the hub, then a bearing, gear, and then the slider. Again, the slider is directional. Tapered teeth on the top, more squared off on the bottom. On these, it's also very easy to tell because the bottom is unfinished and there's a little dot here. Let me wipe it off so we can see it better. You can see the little dot, and this surface is not machined. This surface is machined, and these guys are chamfered. You'll also notice that on these guys, on this slider compared to the others, there are 2 missing teeth at every 3rd quadrant, and the hub for it has cutouts. So
it's just like on the transmission.
Exactly, and it's because originally when these cases were designed, they actually had a synchro ring in here.
Yeah.
Because they figured, if people are going to shift on the fly. But then they realized that that synchro ring is really unnecessary. And I believe after 1992, they went away from the synchro ring, but kept everything else the same. And if you happen to really one with a synchro ring in there, you can leave the ring out. They're superfluous. That's our big word for the day. Another bearing to support the gear. And just sit that in there so you know where it came from. And then we actually also need to take this sleeve off. And this hub is also splined onto this shaft. So you can see there's a separation here. So the sleeve starts from here, goes to here, and this hub is down below it. That has to come off in order for this gear to come off the shaft. For some reason, Toyota decided that the ID of this gear in here is smaller than the OD of this hub. It would have been really nice if it wasn't, because then you wouldn't have to press these apart. But in this case, it's like 50 thousandths of an inch difference, and that gear will not come off of it. If you're only replacing bearings, then you can stop here and put it back together with new bearings. We're replacing this gear with a low range gear from Sumo Gear. So in that case, we have to take this entire assembly apart. So we'll do that next. Again, get this guy on here. And to do it, it's almost impossible to grab this sleeve down here. There's just not enough room. And underneath here, it's almost a perfect mating surface. There's no way to get a puller in there. So we're gonna use the jaws on the big puller, come in here and pull on this hub, which will then bring the sleeve and the hub up in one shot.
And so obviously you wouldn't want to pull in these areas where they had the synchros, right? Or for
Exactly.
Because you could end up chipping and breaking those, right?
Or slightly distorting it, and then that slider is not going to want to go back down over it. We're going to have to go, since we're on opposites, we're going to go something like this. So we don't get too close to these windows.
Yeah. So you end up being right on the edge of that one.
Yeah, you pretty much can't help it.
You can't help it, huh?
So you're going to go just in from the edge on both of them. Make sure these guys are all the way in, and then start yanking. It's a pretty good press fit. This is probably the tightest fit in the entire transfer case, so it takes a minute to get off. Okay, most of the way off. We're not there yet. Again, I stopped because this is a little bit too big for this. We're going to change them out again. And you'll also notice that I usually have my components sitting on rags. It's A, to absorb oil, B, it kills a little bit of the noise, and C, it keeps gears from being damaged. If you have a little bit of cushion in here, when you yank it out, the gear's not sitting there chattering on the bench, so there's no way the gear teeth are going to chip. And it keeps things from rolling away.
Because hardened steel like that chips easy, right?
Exactly, it chips really easy. It can transfer power. If you smoothly apply power, you can put a ton of power through here. But impact loading from the wrong angle will chip these teeth in a heartbeat. Since we have the hub loose, but the sleeve still pressed to the shaft now, we can just pull on the sleeve at this point. Now have our sleeve, the hub. This is directional, if you look at it. So we have a recess here going from the top down. If we look on the bottom side, there's actually a raised portion. The raised portion goes towards the bottom of the shaft here. So it sits down like this. And there's one more little guy here. Even though this sleeve is obviously a really tight fit and a press fit, and you saw that when we pulled it off, Toyota was worried about this sleeve possibly spinning on this output shaft. There's a recess cut into this sleeve for a little locating dowel that will keep this from spinning. If you look really close, there's a little tiny dowel right here.
Oh yeah, you pull that with a magnet, huh?
Exactly. It is minuscule, so
Okay.
that goes in here.
Okay.
That dowel I set aside. A lot of times I'll take it and put it in a Ziploc bag so it cannot get lost. Sometimes I do the same thing with little detent balls or check springs, something along those lines, but set this guy aside. It has to be in there. Okay, so since we are re-gearing this transfer case and we tore the shaft this far apart, or the assembly, the output cluster, we need to remove this gear from the cluster. Go upside down. It's actually a press fit at this circumference, a very mild press fit. Put it on a rag and very gently keep a hand underneath it, tap your way around. And you see that the gear is heavily recessed on one side, flat on the other side. So recessed side slides down onto this hub. And then that's as far as you can tear the output cluster apart. Okay, the last portion of the teardown, I know it's been quite a bit, judging by the bench and how full it is. Again, this is why you want to lay stuff out and keep it separated so you not end up with a giant parts pile and can't remember where anything goes. Although the factory service manual is a great help, videos, picture documentation on your phone, whatever you can do to help you remember how this stuff goes back together. So, input assembly, pretty much the simplest out of the bunch. We saved the easiest for last. And this thing has 3 snap rings on it. We already took one of them off that holds this bearing in the rear case half. Now we need to get this snap ring off. They're always pretty snug. So piece of 1.5 inch tubing, a little conviction. Almost. Here we go. This snap ring is very, very similar in size to the one that retains the viscous coupler to the rear output shaft. That's why you want to keep your snap ring separate. So we're going to put this with the other snap ring that came off the input assembly already. So we need to pull this bearing off. On this particular one, we use the same puller, but there's no need to put a bolt in here. This is slightly chamfered. Our puller is slightly chamfered. This serves no other purpose at all. So even if we distort this a little tiny bit or gouge it, it's not going to hurt anything. In this case, it's very important to remember to install that bearing the right way. And we'll go over this when we do the assembly. The snap ring groove has to be at the top of this assembly so the snap ring's in the right place. If you go upside down with it, then there's no way the snap ring is going to retain that shaft from moving back and forth, and you won't be able to install it. And that will definitely damage the case. So again, sit the bearing on the bench the way it came off. Sad but true, we now find our final snap ring in the entire assembly. I think there are 8 or 9, or I don't know, you lose count. Anyways, that snap ring retains the input gear to the input shaft. Usually they don't put up a big fight. You might need some bigger snap ring pliers. These snap ring pliers were just barely big enough to get the snap ring to open far enough to go over the splines. So what you can do at that point is just get a screwdriver in here and walk it off a little bit. Get it in here and pry on it a little bit. Just go gentle and it'll come off. Then we can try the pliers again. There you go. Again, keep that with the other ones. Now the only thing left to do is we have this gear that's splined on, and you can see that there's a recess on this side of gear and a fairly tall hub, and then a bearing is also pressed onto the shaft. To press apart the input shaft assembly, you can use a 20-ton press. It doesn't have to be anything fancy, nothing like the rear or front output we pressed apart on a 50-ton press. It doesn't have to be as wide. This is a cheap Harbor Freight press that we got a while ago, and we just got some better press plates. The plates that came with it were terrible. So we bought some really good press plates, and all you're really going to do is just support the bearing and then press the shaft through the bearing and the gear at the same time. Again, the initial push is going to be pretty heavy, but then it should be pretty smooth going through. You can press the gear off first and then the bearing. It makes it a little easier. I always press both of them off at the same time. Then I put my hand underneath to catch the shaft so it doesn't hit the ground. There you go. That guy out of here. That's your input shaft, gear, and bearing. A good idea to carry them over to your workbench, way they came off, so you don't flip anything upside down and put it in the wrong way. Looking at these one more time now that we have them pressed apart, you can see that the gear, the way it came off the shaft, has a raised lip here on the recess, where on the other side, it's flat and has a recess in here also, so the splines can come all the way down in here without bottoming out. The bearing takes up this space, so there's really no way for the splines to bottom out. This bearing can go in right side up, upside down, doesn't matter. And our shaft.
Here's a good shot of all the pieces torn apart for this transfer case. It's not for the faint of heart. There's a lot of things going on here. So like George said, you want to be organized and not screw yourself up by not being organized. So whatever way you can figure out to stay organized so you're not guessing what parts go together.
Okay, so as you can tell, we have the workbench cleaned up. The only thing we have left here from the old case is the old low range gear set, the rear case half, and the main transfer case half. And we have marked the case with this orange paint marker to show where the case needs to be cut. There are 2 oil baffles that need to get cut, 1 in each case half, including in here. And on the rear half, we also have to cut this portion of the case away. It doesn't really structurally affect the case. This only supports a shift rail that's supported on both ends, so there's not a problem with making the case any weaker. And as you can tell by my markings here, we're not going to cut all the way into this bore. We're going to kind of split the difference here and cut half this off and then trim it down. The reason for that is that our gear set is physically shaped differently in diameter than the original gear set. To get the lower gearing, because you're going from 228 to 1 to 3.15 to 1. So we're running more or less a smaller pinion, if you would, on a differential and a larger ring gear. So in this case, it's a smaller idler gear, drive gear for the low range, and then a larger output gear for the low range. So the original gear would sit in here like that and right in that bore. The new gear, if you compare the two, it's quite a bit bigger on the outside diameter and will not fit in here. So we're going to cut part of the splash guard out and part of the case here so that gear can drop down in there. When we modify these cases and cut the cases, you can use an air tool with a 90-degree grinder on it. You can use pretty much anything. I like using an electric angle grinder, and we're going to cut right along here and then deburr the sharp edge. We're going to do the same thing in here and then cut the aluminum here. I like using the cutoff wheel because it'll literally cut through the aluminum too, so I don't have to change tools or whatever. Realistically, and some people have asked, they said, hey, these splash guards only riveted in place. Why don't you just cut the rivets and take the whole thing out? On the main case half, that would work perfectly fine. And that way you have less chance of any little burrs or material being caught behind here after you cut the case. But on the rear extension housing, you see this metal tube right here. And we talked about this earlier. This is actually part of your oiling system for the transfer case. There was a little screen we unbolted. The screen goes here, it filters out any big particles, then the oil gets picked up here, goes through the tube on the backside, and comes back out here, and then feeds into the oil pump. There's an O-ring that goes in here. That's part of the rebuild kit. If you were to cut the rivets out and take this whole shield out, then this tube would fall out. It would not be retained in any way, shape, or form. And then you would rely on hopefully being able to pick up oil from here. But at that point, there's so much oil moving around in air that you probably would never get any oil flow from here. So highly recommend you cut the shields instead of removing them altogether by cutting the rivets out. And the rivets can stay in place. You just have to make sure that after you cut these guys, they go through the proper cleaning procedure. In our case, that's a solvent tank where we flush everything out really good and then they go through a parts washer. Generally speaking, we do not beat blast these cases because there's no way to make sure all the blasting media that's trapped behind here can be washed out. And the last thing you want is blasting media or any similar contamination or abrasive to be left in the case, and you put the case together and start driving it. That's a good way to get some serious wet sanding done inside the T case and will destroy it in short order. So let's cut these cases. Obviously, it's not going to be perfect since we're using a cutoff wheel and you might nick the aluminum a little bit. What I do when I cut the case is I literally watch on the back side here. And when I see the sparks comes out on this side, I move on. That's why I start with cutting a small groove and then I work my way all the way around. And then we'll come in here with a sanding disc and a Brillo pad style disc and then like a little flap disc and deeper all these edges and get all these nasty sharp edges off of there and any small particles just to make sure that they can't break loose and get into the T case. If you nick the case a little bit, it's not going to go through. This case is at least a 1/4 inch thick in all spots. So if you just touch it a little bit, don't get stressed out about it, perfectly fine. Just make sure you deburr all these and get rid of all these little sharp burrs that are in there. If one of them breaks loose and goes through your gears, it's gonna cause some damage. Now we'll cut the portion of the aluminum right here to create clearance for the gear, and then we'll sit a gear in there one more time. There you go. And then you can come in with a little sander, like a little 90-degree air tool. Use a little sanding disc, clean that up a little bit, and it'll be good to go. And you'll see that, yeah, we cut down a little too deep. This touched a little bit, touched over here, touched over here. Not a big deal. These cases are more than strong enough. You'll never see one break or fail because we cut into it a little bit.
All right, this concludes part 2, where you saw George finish the teardown and also show you how to do the modifications to the case to fit the larger gear. Join us in part 3, where you're gonna watch George start the rebuild process of this transfer case with new bearings, new bearing races, new seals, different gears, the whole 9 yards. See you there.